My name is Kevin Daly. The title of my talk is a CSS Importer for Wolfram language. It basically takes the CSS format and imports it to Wolfram language options, usable in any of the styling you want to do within a notebook. So my name is Kevin Daly. I'm a user interface developer in the front-end team at Wolfram Research. I'm going to talk about a CSS importer I developed exclusively in the Wolfram language. And if you're not, so I was hoping that the audience would be familiar with CSS Wolfram language style sheets altogether, but if you're not, I'm hoping to keep us all on the same page. So the CSS cascading style sheet is a standard for HTML, and this is how you style web pages. Does not mean this is content. This is how you style things. But CSS is not just for HTML. It is basically goes along with XML, so things like SVG, which is an implementation of XML. CSS can be used to style SVG. And what I wanted to do is figure out how to take the CSS standard and the Wolfram language style sheet system, which are completely independent of each other, and try and build a bridge, at least in one direction. And hopefully I did a good job on that. Anyway, the goals of the project that I had set out to do is, for one, don't do anything hacky. I mean, we can do a lot of cool things with like attached cells, try and make like multi-column things and ridiculousness. But the more you hack at the system, the slower it'll get, and the worse it'll be to actually maintain. So the other goal I had in this project is to follow the CSS specification, because I am going from CSS to Wolfram language. If you're not familiar with it, it started with this core CSS 2.1. And then each of these individual modules sort of grew out sort of semi-independently of each other, but they always are based on the core. And what I've circled in light green are the different modules that I've been able to implement. But I have to use that word carefully, because this doesn't mean that the Wolfram desktop supports all of the CSS features. For example, speech, which is in the sort of lower right there, or some of the animations and things. So maybe in the future, as the Wolfram desktop sort of evolves into the features that it has, then also this project can evolve with it, because the intent is to have this be an open source project on GitHub, although it's not quite there yet. So I've done the core. I've implemented, which means I've basically, this works as a CSS validator as a first base. So there's a really good tokenizer that underlies all of what's going on in this project. And what that allows me to do is basically I've done validation of everything that's W3C recommended, that's the worldwide consortium, and some of the candidate recommendations, but again, this is an older diagram anyway from 2017, and technology and the web moves very quickly. So what do we get with my new importer? There's basically 6 functions that I've introduced. One of them is now we can actually import with the CSS extension. So that'll basically let us import the CSS text files. But there's also CSS, as I mentioned, found in any XML. And so this is actually, the extract CSS from XML can pull all of the CSS data from any XML, symbolic XML document. And then there's the whole sort of sub-language with CSS selectors and targets. I'll get to talk about those a little bit later. And then really what the meat of this is I wanted to create a project where you could actually use the CSS language in the Wolfram language in the styling. And so the CSS Cascade and inheritance functions will perform the CSS algorithms and then ultimately resolve to Wolfram language functions. And to keep us on the same page, if you're not familiar with the Wolfram language style system or the CSS one, this is sort of a comparison. That's the closest one-to-one comparison between the two standards. So at the top half, you'll see the Wolfram language, which is a style data cell. And the lower half is the CSS sort of analogous style rule. The first thing you'll notice is that we have the option name. In CSS, they call this the property. And then we have the option value, which is just the value in CSS. The entire thing, we consider this an option, which uses the rule syntax with that arrow infix operator. And in CSS, they use a colon to delimit this. And white space is arbitrary. And you can have many Wolfram language options just as a sequence kind of at the tail end of the expression. And in CSS, they actually need to block this with curly braces, and then it's delimited with semicolons, and we in Wolfram language just use commas. And we style this in the Wolfram language, or we name this style, and that's how we can access it from the style sheet. And so we often see things like title, section, etc. as the style names. And in CSS, this actually gets much more complicated. Again, this is the closest one-to-one analogy. What I have highlighted in the CSS section is a class selector, but you can have many more complicated selection mechanisms using the CSS selector syntax. And then lastly, we call this thing the style data cell, and a style sheet is made up of many of these. And in CSS, this is called a rule, and the style sheet in CSS is just many of these rules. So now we know the analogy, and you're like, hey, if that was that easy to compare the two, you're basically done, right? But there's a lot of nuances here. The hardest part isn't really parsing the structure of the CSS, which is just plain English. The harder part is actually finding those translations to Wolfram language options. So I'll go ahead and load the package. And just to start off with sort of a very basic text-based CSS, you see I've already hooked it into the import-export mechanism, so we can directly just use import string, for example, on this text. And what I've tried to do is this is more like a semantic import, where the structure is supposed to mimic what you would normally see on a CSS object. And so in this case, we have the selectors on the left, we have a block of properties on the right, and the additional things that you see are the interpretation and condition columns. So the interpretation is the Wolfram language interpretation, and then the condition is things like media conditions. If you have, say, if you're in the printing environment, the condition will show that it's a current value of being in the screen style environment of printing. But for the examples I'm going to use in this talk, I'm not going to do anything that involves condition, just to keep things a little simple. And if you're familiar with CSS, this important column, you can actually flag different CSS properties as being important, and then they'll have, in the inheritance structure, they'll actually be effective instead of the ones that are not important. Another thing to notice is that the selectors are sort of like a sub-language in themselves. I've typeset them as these rounded rectangles, but what they actually are under the hood is their own sub-language. So we've got basically the raw string, as well as the token sequence that they actually represent. We do understand namespace, although these examples don't have any namespace. And then the other property of this is the specificity. And again, this is a strictly CSS idea, where different selectors, depending on which selector types you have, will increase the specificity, and therefore those rules will take precedent over rules with lower specificity. And it's just counted left to right using the integer indexing. So one of the underlying things of this project is to have a really good tokenizer. And so what we can do by having this good tokenizer is we can pretty much instantly understand when syntax errors occur. So to start is the selector that we had before. And you can construct selectors using the same head as the CSS selector with just a single string argument. And if you do this and you create a bad one, then we can identify exactly where the badness occurs and then tell the user potentially how to correct it. So in this case, this was a bad combinator. CSS has a number of combinators, like the greater than sign. Or if you have a bad attribute, this will highlight the attribute selector that's bad. And like I said, we understand namespace. So if the namespace was not declared in the CSS file using the @namespace declaration, then we would recognize that as well. That didn't go all the way down. Other things, so beyond selectors, if we just want to look at CSS as a structure, if you are trying to validate the CSS, and in this case we don't have the property, it's not invalid. What happens is when you hit a rule or a declaration that is not understood by the parser, the specification says just skip it. So that's why we have this empty block here. It doesn't mean that this is incorrect, It just won't do much if you want to use this later. Or if you have an unknown property value pair. Again, this is not invalid CSS. That's why we get this data set structure. But the interpretation, because Mathematica or the Wolfram desktop is the user agent that's going to be interpreting this, then it'll just be indicated that this is an unknown property. So again, we won't be able to use this in the Wolfram language. Or lastly, kind of the more insidious errors. In this case, the font size was not specified with a dimension. And so in this case, I can't really scroll to the right, but this indicates that the dimension was missing. So again, it's valid syntax, but an improper interpretation.
Kevin, if you change an N77 then unknown colon value to foo colon bar, what happens?
This one?
Yep, foo colon bar.
Ooh, I forgot you can't arrow over. So the point is that the interpretation or the import to the dataset structure is pretty robust. You should know exactly where any errors are. This is really the validator. So now that we kind of know how the data structure looks like, we can do some things with it. And this is what I expect most users to really want. So you've imported the data set, and now you want to actually extract the Wolfram language options. And so we use this function that I've named CSS Cascade. The names might change in the future, but for now, this is a pretty good starting point. So what this actually runs is the CSS Cascade algorithm. So this is not quite inheritance because it only needs the data set itself to run the cascade. And so this takes 4 arguments. The first one is the property you actually want to extract from the data set. So you can either give it in a list form, a single property, or in this case, I'm asking for all of the properties of this data set. The second option, if you actually attended Jason Harris's talk, you know everything is a box. But in the Wolfram desktop system, we give more emphasis to boxes, cells, and notebooks. There's kind of this scoping of those. And in the web and XML, everything is a box at any level. It's just a type. And so to do this conversion to Wolfram language, we also need to indicate the scope that we want to do this conversion at. And so in this case, I'm just asking for these to be cell-specific options. The third argument is just the data that we're actually operating on. And lastly is a way to select different rules from the data set by using selectors. You can either do it as a string, a list of strings, or selector objects. And again, in this case, I'm asking for all rules. And I know all of that description for a very not exciting end. But the idea is this is the function that you're going to use to actually pull any of the options you want and directly start using them as styles. This I might go through a little quickly. This is to convince you that we're actually following the CSS Cascade correctly. So in this case, we have 4 different rules. Some of them are important, but they're all talking about the font size. So which one is actually going to take effect when we run the Cascade algorithm? Why do I not have specificity? Huh. Anyway, I'll skip specificity. So at least with importance, so the header and H classes, they have the same specificity because they're both classes, but H has the important flag set. And so if I were to run this Cascade algorithm asking for both of those rules, the one that takes precedent is the one that actually has the higher importance. And then order also matters. I clicked on it and it appeared. So in this case, we have the H and header 2 classes. They have the same specificity and importance, but the header 2 rule comes last. And so that's how CSS determines those tiebreakers. So, but that's not the only place that we can get CSS from. You can also get CSS from CSS, sort of this nested thing going on. So what I mean by that is in some files you might find an @import statement, and that'll actually look relatively or with an absolute path to another CSS style sheet. And we understand this, and therefore can actually just prepend all of these. That's effectively what it does. The add import statement pretends as if you've completely just concatenated two style sheets together. And we can do that. You just have to be careful about making sure your path is correct to actually find the relative files. So I mentioned earlier, the other place CSS can live is just embedded in XML. So if we have, say, a web page here, which I've prepared for this talk, you might find a style sheet in the header, or maybe linked to an external style sheet. You might have weird style blocks sort of oddly placed in here, or you might even have inline styles in different elements. And if we import as symbolic XML, then we can use the extract CSS from XML function to actually pull these rules out directly from the symbolic XML. The structure is the same, except we have a new column, targets. This is a bit awkward. I'm still trying to rethink about how to present this. But those targets is the actual expression position of those XML elements in the symbolic XML. So this is actually telling you which rules or which elements these different selectors are targeting. I'm only showing the first three rules here of the style sheet. So then how do we actually use this information if we have an XML document sort of behind this CSS style sheet? And one of the things that we can get from this is the inheritance. So inheritance doesn't make sense if all you have is the style sheet, but if you have the document, then you can start to think about it. So in this case, these two rules from that style sheet we pulled out in the last slide, you'll see that the H1 element is a descendant of the body element, just because we know in Wolfram language the position is more deeply nested there. And the thing that we notice is that, if you're familiar with CSS, the color property is an inheritable property in CSS. So if we were to just run the cascade, we would actually miss the color property. And so we have another function, CSS inheritance, that you give the position of the element that you're interested in, and it additionally runs the inheritance algorithm to pull any inherited properties into the list of Wolfram language options that it resolves. Now, I went through a lot of rigmarole to show you how to sort of play with some of this data by hand, but if you're sort of lazy, you can import directly to a style sheet. The downside to this is that there's no restriction on the style name that you can use. And so what I've done is I've just taken the selector, and that's what I've used to name by default the different styles. So in this case, I've just chosen an easy one, H1. But if I made this like H1, descendant H2, then you get some pretty ridiculous style names that might not look so fun in the Wolfram language, but you can still use them. Or if you just want to understand or analyze the CSS data itself, you can do the raw data import, and you'll just have no interpretations. This is actually the fastest import because the interpretations are actually the bottleneck of this importer. And even though I don't have a CSS exporter to go along with this, this would be the easiest stuff to re-export back out to CSS format. So what I hope to do is continue this project. So this is what I've been doing in my vast spare time as a front-end developer. My coworkers chuckle at that. So one of the motivations I actually had for this is I wanted to make an SVG importer. And then I realized since SVG is just an implementation of XML, it needs to be compliant with XML. It needs to understand CSS. So if I actually want an SVG importer at some future date, then we should probably have a CSS importer that understands all of CSS. And the reason I wanted to make this open source is this is way too big for me. Like, the web is expanding very quickly in its technology. And like, I've only done the core and a few of the level 3 modules. And as it keeps going, maybe other developers could work on including other properties. And if you want to do all this, it's actually fairly documented. So I made sure to write fairly good documentation. And so within the package itself, there's quite a much larger tutorial trying to show the comparison between the Wolfram language and CSS. And in the future GitHub page, there's also already instructions on how to add to this project once it becomes available to the public. And well, there's no speaker after this talk, so should I continue, or do you want questions, if you have any? Because I have 2 bonus material slides. I'll try and get through them. Okay, so one of the cool things that we can do in the Wolfram language now is start a web session. So what I've gone ahead and done is started a Chrome session using the start web session function. Then we can do things like navigate to the Wolfram homepage, and then do fun things like grab all the P elements, the paragraph elements of that page. And then if you know JavaScript, you can do some things to pull out the property and value pairs of the page, of those paragraph elements that we pulled out. And then you'll notice that there's actually 280 properties that we just pulled from each of these paragraphs. So each paragraph has 280 computed properties. But we only understand 71 of them. So there's room to grow here. But we get some of the more core ones, like fonts, colors, and margins. And so the kind of cool thing is you could basically programmatically navigate a web page and then say, hey, I like that item on that page. I want to see its properties. And then through a little bit of JavaScript, you could just directly import, use the Cascade function, and so pull things like font color, which is this nice gray color. So I'm pretty sure I pulled out this first paragraph here. But anyway, so that's one sort of workflow that I foresee in the future. The other workflow I foresee is working with symbolic XML. So this is more getting your hands dirty and to convert directly to a Wolfram style sheet. So I just have a helper function here to create style data cells. And this is using the same XML data that I had imported before. And so what I can do is make a body cell style. And then I can pull out some other styles like H3, H1, list items, etc. I have a special case here, which is an element, an XML element that's very similar in style to another one, except for just the color changed. So I just complement those two together. And then, long story short, we've got a nice style sheet with all of those styles that we wanted to have. I can save that style sheet, and then here, my grand finale. I don't want to start in save mode. Whatever. So what I have on the left and what I have on the right is the Wolfram Language Notebook, and on the left is the content and styling of this basic web page I made. So I don't think that's too bad. It's got the background, the text. Yeah, so hopefully in the future this will get even better once more features get added. But thanks for your time, and I'll take any questions.